The next one we want to look at now is the RS flip-flop. Okay, so for the RS flip-flop, you agree with me that you have your set bit 0011, reset bit 0101, and then you will have your output to be for set bit, for reset set bit, reset set flip-flop, your set dominates, right? So when the two of them are not pressed, 00, you have 0 here. When the set bit is not pressed, but your reset is pressed, you have 0 here. When your set bit is pressed, but your reset is not pressed, you have 1. Now, but when the two of them are pressed, because set dominates, you have what? You have 1 here. That's the idea. Already, they don't need to tell you before you know that this particular instruction will not what? Will not work. But at the same time, I can still repurpose this particular what? Program. So I still have my normally close of the stop button, the I0 dot I0 dot 1, I0 dot 0. Abi? So this I0 dot 0, am I correct? So then my start I0 dot 1, the start, and then your output. Okay, let's say Q2 dot 0. All right. So and then the latching that we have here, Q2 dot what? Dot 0. Are we together? So now this is for SR. Now, how do we now infuse RS here? What's the condition for RS? The condition for RS is such that when the two buttons I0 dot 0, that is the stop, and the I0 dot 1, the start, when they are pressed, okay, we still want the set to what? To dominate. So let me represent this one as M0 dot what? M0 dot 0. So at that point, I can bring M0 dot 0 here. Which bypass this initial condition. Okay, so what will be the case? Now let's test it on this our truth table. When the two of them are not pressed, there is a signal state of what? Of 0 here, 0 here. So there's an inversion. This is 1, and this is what? This still remains 0. 1 and 0 will not agree.